Hi, Clément. It's a pleasure to meet you today as you're a speaker at the CADFEM Conference 2024 and are giving a presentation on multi-scale analysis of rice milling process with particle simulation. Can you please summarize your presentation for those who did not attend your talk?
Yes, thank you, Urs. So today I explain how Bühler is using particle simulation to optimize our widener. So Bühler is a company which deliver equipment for rice milling, and basically it's a very important process for our customers, but also for the world, because rice, as you know, is one of the most important staple food. So billions of people are eating rice. And one of the biggest problems that we have with this process is the numbers of broken. So a lot of grains are getting broken. It can be until 20%. And it's very important for our customers that they have machine where they can reduce the number of brokens, but also for to reach Bühler sustainability target. So we are investing a lot of research and development and effort in order to optimize our rice whitener to reduce significantly the numbers of brokens. So in my talk, I present it in detail. This simulation setup, what we are doing, and what will be the next steps.
Okay, interesting. But at the beginning, who did initiate this project at Bühler? Was it a need from the customer from Bühler, or what is the background of that project?
So yeah, so we have these rice right now, which are used since years by our customers, and we know that there are like pain points. So they are there, and it's like something which is well known by the R&D team. And we have on the other side simulation team from Bühler in the headquarters, which is aware about what can do the numerical simulation. So we have a lot of discussion, of exchange, and then together, so between the simulation expert and the R&D engineer, also I would say the process engineers, we have this agreement to say we can really do something. So we can start a simulation project to optimize our rice whitener.
Okay. During the project, what challenges you were confronted with?
Yes, first I have to say the rice, to make a particle simulation of rice whitener is very challenging, because it's a complicated process with millions of grains that we have to calculate. So the challenge that we have are like, the main goal is like to be able to reproduce correctly the rice flow behavior. And it's something we have we can do well with Rocky. But the challenge that we have is that we need to develop method to be able to predict the breakage, or also the degree of milling. And for that, we need a good simulation method, but we also need a good experimental know-how. So we have to combine this competence to make the best usage of simulation for us.
Okay, so as I understood, this is a complex simulation and not very easy. So how do you verify your results?
So we have the chance that we can get data from our customers. So we could make some trials or some customer place on rice whitener, where we could put some plexiglass wall, and then we can visualize very well the rice flow. And this allows us to make qualitative verification between the rice flow that we see in our simulation and what we see on our full-scale machines. So this is very interesting. And in addition, we can get data about the number of brokens. It's quite easy to measure, or also the degree of whitening, depending on some process parameters. So these are data we can use to validate our predictions.
Okay, can you just say something about the simulation, so runtime, or when start a project and how long does it go?
So here it's R&D project, so we really we have to think really long term, because if you think about how many people are using rice and how much potential we can have if we reduce the number of brokens, or if we reduce the energy consumption of these machines, it will be extremely beneficial for us, I mean, for Bühler's customers, but also for sustainability. And we set up this project with a long-term perspective, so we have to build this know-how. And we started by making some benchmark on the first question was, is it possible to simulate the full scale machine with Rocky? Or now we know it's possible. And our next steps will be to go really into the quantitative predictions of broken and of degree of meaning.
Would you say this project was a success?
Yes, it's a success because we know that's possible to generate a full-scale simulation model of the Reis Widener. So we already learned a lot from it. Also, if we are just by really analyzing the mechanism and the influence of process parameter on the machines. So these are already data that we can provide to our process engineers, and they can directly apply it to have let's say to make the best usage of our existing machine at our customer place. So this is already a success, but the real success we'll know it in some years to see for the development of a new machine. If we succeed, we'll use the simulation now that we have made with this project to increase the performance of our machine. And this is how we'll see our success. And basically, it's not me who will see if it's successful, but the customer will see it in some years.
Did you see some potential to apply the knowledge you get from that project to other processes at Bühler? Because Bühler did not only machines for Reis.
Yes.
So are there any benefits for other processes or machines?
It's an excellent question. So we have Bühler is a leader in milling solutions. So we have to deal with a lot of different variety of grains that we have to process, to treat with a huge range of machines and equipment. And the know that we built here for Reis, we can extend it in the future for other material, like for example for wheat, for maize, for lins. And it's not only just for this specific project. We are building know-how that will be useful for other departments for Bühler. And this is why for us it's very strategic.
So we can say this is a core simulation technology for Bühler.
Yes, we can say that.
Exactly. Okay. Are there some requirements to do simulations like this, or you just can use your traditional or normal hardware?
We decided some years ago to invest in GPU, so we have the possibility to run quite, let's say, huge particle simulation model with the hardware that we have, because one of the biggest limitation of particle simulation is computational time. So we had to invest on hardware, and because for us it's strategic and very important, we decided to have the hardware and also the simulation team to do this work in-house.
Okay, and if we talk about size, just to get an imagination, how many particles you have in your model?
We can work with more than 10 or 20 millions of particles in our simulation model, but you have to be a bit patient because the simulation time can take several days. But I would say it makes sense to wait a few days according to all the knowledge that you get from this simulation, because it's just amazing, all the information that we can get the force between the particles, the contact, the interaction, the stress, and it's giving us so much information and key knowledge for a process that it's better to wait a few days to run this simulation than not to doing it.
As you said, right now you're able to get qualitative results of your process. Are you at the end at this topic, or do you have plans to extend the simulation? What are the next steps?
Yeah, we are going to extend this project and to invest more on research on that, because what is very important for us for Reis is to really understand the tribology, so how does my grain interact with another grain or with a surface like abrasive stone? Because if I have this knowledge and I combine that with the simulation result that I have, we can certainly have very precise prediction model for de-link or for broken. So it's something we are currently working on that. And as you know, one difficulty is that you have so many variety of rice and so many, so there are like 40,000 rice variety, the different size, different moisture content. So we have also, one of the challenges also is how we can use like statistical method to take into account of these uncertainties. And it's something we build with the time as soon as we get also measurement data.
Okay, so there is some work to do.
Yes, but it's
to get to the final end, and
yes. But it's a necessity to do it because it's really what we need to reduce waste, because you know food waste is a very important problem for humanity, and as for Bühler, it's our responsibility to tackle this problem and to be able to treat that. So let's say if we succeed to reduce the number of broken from a few percent, it will be already a big, an enormous step forwards in terms of reducing food waste. So it makes sense to tackle challenging problems. Yes.
Okay. Yeah, thank you very much, Clément, for this explanation. And yeah, we are looking forward to see the progress on that project in the next CADFEM conference,
exactly.
Maybe.
It will be a pleasure to share that. Thank you.
Thank you.